Okay, so I wanted to talk about today how to start understanding the different organic chemistry mechanisms. And so the best way I think to start and to organize it is to make a chart. So you have your SN1, you have your E1, your SN2, and then you have your E2. So the four things you want to pay attention to is your alkyl halides. So we have to understand what that is. So your alkyl group, so alkyl halide, your alkyl group, if we break up the word, is your carbon chain. And your halide are fluorine, like fluorine halogens, right? Like fluorine, bromine, chlorine, etc. Okay. So we're gonna have that as the first section. So alkyl halide. So SN1 is going to be it'll prefer tertiary over secondary. It'll never do primary, right? So what is that? So tertiary is you have a central carbon with 3 carbon groups. They could be anything. The point is that this central carbon has 3 carbon groups attached to it directly, right? And then you have your halide. So your halide is your X. And then your secondary, you're gonna have your central carbon, and you're gonna have 2. And then remember that each carbon has to have 4 bonds attached to it, right? So that third one will be a hydrogen, and then you have your halogen, right? So this is your tertiary, and this is your secondary. Okay. For E1, exactly the same. Okay. SN2 likes primary over secondary. I apologize if this view isn't the best, but it's what I've got right now. So primary, central carbon with only 1 group attached. The other 2 groups will be hydrogens, and you'll have a halogen. Okay. And then E2 can be primary, secondary, tertiary. Okay. So for next section, nucleophile and base. Okay, this will be a separate video, and I would go on over what is the difference. So for SN1, it likes weak nucleophiles, weak bases. Okay. E1, the exact same. SN1 likes strong nucleophiles, weak bases. Okay, and then E2 likes weak nucleophiles and then strong bases. Your next section is going to be heat. So heat preferably drives your elimination reactions. So if we're talking about a substitution reaction, it's not going to prefer heat. Elimination will prefer heat. Your SN2 will not like heat. And your E2 prefers. Now, E2 can happen without heat, but again, it's elimination, so it's going to prefer that. Okay, and then products. Now, depending on who your professor is, they might care about the different racemic mixtures, so I'm just going to put this in here for completeness sake. So racemic mixture for SN1, and in more videos to come, I will show some examples of what that is. Now, this video is just a chart, how to differentiate between SN1, E1, SN2, E2. Okay, so racemic mixture for SN1, you're going to get the R plus S enantiomer. For E1, your product is going to be an alkene, which is a double bond. SN2 is inversion of stereochemistry. Now that only applies if the original structure, that carbon had 4 different groups, right? So for SN2, inversion of stereochemistry. So if it started off as the R enantiomer, it's going to become S. If it started off at S, it'll be R. Okay. Now for E2, products. Again, it's an elimination, so you're going to have an alkene, double bond. Now, depending on what the reagent that was used, if it was bulky, so if you originally had a bulky base, you're going to get the Hoffman product. I will explain this in more videos to come using examples. This is just, again, a chart how to differentiate everything. Okay, if you had a small base, Zaitsev product, which is the more stable. So Hoffman, less stable. Zaitsev is more stable. Okay. Now for the last part is going to be solvents. Again, this is another one that's more in here for completeness sake, but for solvent, this only applies to SN1 and SN2. So SN1 likes polar protic, and then SN2 likes polar aprotic. Okay. This is very useful. I'll kind of zoom out so that you can take a screenshot if you want. This is very, very useful as a first thing to kind of memorize. I hate using the term memorization, but this is really good to memorize, and then use this chart to go back when you do examples to see what reaction is going to be performed.